Engineering. This is the third in a series of Invitation to Learning Engineering seminars that is being put on by the IEEE ISICLE. ISICLE stands for the International Consortium for Innovation and Collaboration in Learning Engineering. And the first was sponsored by, driven by the PK-12 Market Interest Group. The second, the Higher Education Market Interest Group. This is the Government and Military Market Interest Group. And the next one is going to be by the Workforce Market Interest Group, and we expect that's going to take place in October. And what you'll see is some common information, but then we'll dig deep into a use case around learning engineering. So welcome to everybody. We'll be doing, as I said, an overview. Then we'll be going into a use case. We'll have some live Q&A, and please feel free to put your questions as the session's going on in the chat, and we'll make sure we come back to those. And then we'll talk a little bit about the structure of ISICLE and how you can get involved. So yeah, our main speakers for today, excuse me, our main sponsors for today are the two co-chairs of our government and military market interest group. And those are Eric Oltes, and Eric is with CAE. And we have also Lieutenant Colonel Jason Virtue, who is with the Royal Canadian Air Force, part of the training innovations group there. So
All.
did I get that right, Jason?
100%. All.
Wonderful, wonderful. So, I don't think there's anything else I need to say. There will be a recording of this made available on the ISICLE website afterwards. So you don't have to frantically jot down notes unless you want to, of course. But you can find that, and you can also steer your colleagues to that as well. So with that said, I'm going to turn this over to Eric and Jason. Eric.
Thanks, Michael. Kevin, next slide, please. So I want to kick off with what is learning engineering? First and foremost, learning engineering is a process, meaning it's repeatable, it's measurable, and it's improvable. It's also a practice in terms of how we apply that use the learning sciences, human-centered engineering design, and it's data in a form, means we're using empirical data to achieve outcomes. And for the government and military context, that's really tied to usually mission readiness sectors. In the bottom, from the Learning Engineering Toolkit, there's a definition defined there. It's iterative, meaning you're doing it for your analysis, your design, your tests, your adjustments, and improvement. For those in the military sector, ADDIE comes to mind there. Next slide. So it's not just a learning science, because science is about discovering the truth of the world and of how it is. It's using scientific method. It's largely incorporating engineering to make scalable solutions to address real-world problems, whether it's in the military sector, government sector, industry, academia, to achieve an outcome. Next slide. So, a little humor there. There are those who always talk about learning and engineering almost team anathema to each other. Not the case here. I'd use some examples of jumbo shrimp, awfully good. They seem contradictory, but they go together. In this context, the emphasis is on learning. Engineering is helping to achieve an outcome, but learning is the primary focus of learning engineering. Next slide. A little bit of history about how learning engineering came to be. Well, it may be new to some of the folks here. It's not a new concept overall. It's just growing in popularity based on innovations of technology, identifications of pain points in learning and education and training. But it started with Carnegie Mellon back in 1967 by Nobel laureate Herbert Simon. And through updates over time, 2014, they started an initiative to start looking at learning engineering ecosystems. I'm sure many of you have heard the term learning ecosystem, training ecosystem, digital ecosystem. All those are connected thoughts to this. And then the standing up of the IEEE ISICLE International Consortium that Michael had presented earlier. And then we're getting to this pedal diagram here in a few slides, but really identifying the definition of what is learning engineering in terms of practical outcomes back in the 2018-19 timeframe. Also addressed in Learning Engineering Toolkit, which came out in 2022 with many authors to it. In fact, I use this quite a bit. I still have it here on my desk next to me because I use it for most of my ventures. And then most recently, the U.S. Air Force Air Education Training Command I came out with their Enterprise Learning Engineering Center of Excellence, COE. That's just been rolled out recently. So there's a lot of initiatives underway with that government agency, allied agencies. The big thing here, because it's government military, this is an international consortium, meaning we have all our allies as part of this, and we're all working together towards a common goal, because the next time things go kinetic, we're going to be working together to achieve a shared outcome. Next slide, please. Okay, as previously mentioned, the Learning Engineering Toolkit, a lot of questions that come up when we have our market group meetings. We'll talk about it more, but we have them every month. A lot of questions come up is, this is all great and good, but where do I start? Recommendation, big footstop, start here. Pick this up. We'll have QR codes later in presentation of where you can get a copy of this. Other ways of where do I start is participating in the government MIGs and SIGs, whichever's appropriate for you. We'll talk about that towards the end of the presentation. But this kind of gives you an idea of how the different learning sciences, learning engineering, data sciences, instructional systems design, for the TDOs out there, for the operators and maintainers out there, this is applicable CEOs to everybody to say, but why should I do this in my organization? And what's the outcome I should be pushing for? Next slide. Okay, so this is really the why for those who are big Summit fans. Why are we doing this? Well, we need to take what's already out there. So we already have ISDs for ICs out there. We have operators and maintainers. We have data analysts. We have academic folks. We have operator folks. We have technologists, engineering architects, system engineering. All of those play a role in learning engineering. It's not a one discipline type outcome. It is multidisciplines coming together to identify the pain point, the need, establish the requirements and standards, generate outcomes, and then measure against those outcomes to have empirical evidence to say, hey, is this more training effective? Is it more learning effective? Is it more learning efficient? Is it, and or is it more cost effective to the outcomes you're trying to generate? Next slide. And with that, I'm going to hand it over to Jason to talk about learning engineering as a process. Jason.
Okay, thanks, Eric. So, hey, my portion of this slide deck is to explain how learning engineering can be applied to your organization and why it's important to us as learning professionals and most critically to the learner. So first off, learning engineering, and Eric does a great introduction because he keeps coming back to the problem, why we're doing it, operational effect, mission effect. And it's a process that's really fundamentally grounded in the problem. It's iterative, and the problem remains at the core of that process. And second, it's a process that acknowledges that learning doesn't take place in isolation, but within a broader context, between the learning team, but also the organizational context of the organization, where the learning takes place, but also the culture of the organization. And third, and I think most important, is it's a data-driven, iterative process that provides rigor, because learning is one of the most costly and time-consuming processes we do, and we really have to make sure it's targeted so that learners are convinced that when they receive the learning, it's to solve a problem they're motivated to solve. So if we go to the next slide, how I'd like to talk about the learning engineering process is using an exemplar from my work. I was the previous commanding officer of the Royal Canadian Air Force's largest flight training school, and we had a problem. We had 15-year-old software, 15-year-old courseware that was out of date, used Flash, and the only data that we had was that it was only being completed by about half of our students. And the problem with that is our instructors, whether they're in the sim or the aircraft, were backfilling and gap filling information, and that was a drain on our process. So the first thing we did was we created a new system, and as part of that process, we asked, what data do we need during the creation of it? And what we needed was time spent per slide, click engagement. So we chose an LMS that really gave us a lot more granular indication of how students were using the LMS. We implemented the new content, and we reviewed the data, clicks, time spent per slide, and really quickly we figured out that we didn't have a data problem, we had a filtering problem. So that was our next step, is we refined how we interacted with the data, came up with better filters, better triggers. So when a student was spending 25% less per slide, more per slide, and that was part of our investigative process for iterating the second time. But what we had missed when we first started the courseware update was the context of the organization. So our students were really motivated to engage with the flying training because it mattered to their careers, and we weren't engaging them enough in the content creation or validation. So what we actually did was we on each slide we put a button where the student could tell us if they liked the slide, didn't like the slide, or identify a problem. And we increased our team. So we built the product with a company geographically dispersed from us. We actually brought somebody in-house so we could quickly iterate on changes and show demonstrate value to our students that we were going to correct their problems. So the next time we implemented the next version of it, we had tremendous feedback from our students. They were highlighting problems both in the courseware and on the test. And what we found was with 3 iterations, our students believed that it was a good course, and critically that the test was something of value to them. That if you could pass the test and you pass the course, you were good for the aircraft or the sim. So we had really good engagement, and I just want to use that as an exemplar for how we use the learning engineering process to really make sure that our content was loved by our learners. Slide. And I like this. I like this picture. I like flowers, but what I like about it is it's really graphical, and it shows that it's really important that if you're going to come together and build a learning solution, you need a shared understanding amongst a body of people, and that body is expanding as technology increases. So whether you're talking about learning sciences, data scientists, software engineers, AI engineers, it they all come together to deliver an outstanding product with the learners really at the heart of it. Slide. And the last thing that Eric touched on is that this is not a process that lives by itself. It is a process that can go on top of yours, and it's scalable, just like what it's designed to do. You can take parts of it, all of it, and certainly the example used here is if you're bent towards system engineering, this is really something that bolts on top of human system engineering, and it really can work and scale to how you want to implement it. And so with that, I'll turn it over to Kevin. Slide. Kevin
Okay.
Owens from the University of Texas. Kevin.
Thanks, Jason. And I want to thank you guys all for inviting me to this. So what we're going to talk about here is on behalf of Lisa Townsend and Dr. Joan Johnston. We've co-authored a paper that is going to be presented at the AHFE International Conference in Orlando, Florida in a couple weeks. So I thought we would share this with the community because it has a lot to do with how we can integrate learning engineering into the military and government sector. First off, I think we should probably go over some acronyms for those of you who might not be in the military sector. Most of these are standards, and they're available at these URLs that are noted here. The main item that we're going to work around, or the challenge, as we've been talking about for learning engineering, is this idea of learning transfer, which is basically the application of whatever knowledge and skills you've produced in a training environment to some sort of a standard. And what I would say is the actual return on investment in training, or what you might hear some people talk about, Phillips Level 5 evaluation. But we'll be using these throughout the presentation. So this is the challenge, and it's been my challenge for going around 40 years, working with the military, industry, and academia, doing military training, both as a learner, a trainer, a manager, a designer, developer, and an evaluator of military training technology. And in all that time, what I've observed constantly is this phenomena of what I thought I learned, my people learned, those who used my content and training learned, didn't necessarily always pay off as I watched them in the real work environment. And these numbers here that are based on this research that I've cited down at the bottom, it falls within the same parameters that I've experienced and others. So, and the key thing here is what is at highest risk here is the military combat related combats, because unlike other occupations that apply their training almost every day and use it, the military doesn't fight in combat every day, and so thankfully, but we have to make sure that the training is constant and is at maximum effectiveness. And the main thing here is also we don't want to continue low return on investment from the expensive training systems and programs that we're creating. So this is the challenge, and I think this is a perfect challenge for learning engineering to tackle. So I've worked with DoD acquisition and program engineering for many years, and from design, development, validation, verification, even watching those systems go out to the fleet or to the field. And I've noted DoD training, acquisition, engineering, and program development process. And these are sort of my notes. For one, there's no live training data usually collected out in the field or in the fleet, in my case, being retired Navy, to produce a baseline for the learning requirements and the standards that these systems need to be developed for. And this is important because these learning standards need to be what we're testing for, not just the reliability of the system. And to add to that, a lot of the program managers, at least in my experience, and system engineers really don't understand learning principles or the best practices out there. They're engineers, and so something needs to be there to talk on behalf of the training outcome. In addition, there's really no iterative or final testing of the system's learning capability. What I've noted is mainly it's functional testing, making sure the thing works, and whether it's actually effective is a whole other idea. And then this sort of ends up where there's no follow-on training data that's available, or if it is available, it's not transferable to other systems that can actually watch whether these training devices or content or whatnot is actually effective, which is kind of part of the ADDIE process. But that also needs to go back into the requirements process for future systems or for updates to really define those standards and to continuously improve. So before we get into what we're proposing needs to happen, I just want to go into some of these existing readiness levels that are used today. One is these technology readiness levels, and these have been around since the 70s. DoD has used it since the 80s, and in my experience, use it pretty regularly. It's a 9-level scale, and it basically measures the capability and reliability of the technology. Now, more recently, a new standard of readiness levels has been published, which is the human readiness levels. And these pretty much started around 2010. I think they originated out of Sandia National Labs, which is the Department of Energy, nuclear reactors and things like that. And but a whole host of government, academic, and military folks have worked on these, and these were published in 2021 by the Human Factors and Ergonomics Society. So what we're proposing is to riff off of this and add another layer, which is we're calling learning readiness measures. And what this would do would also be a 9-level scale. And the intent of this, and I'll show you some of the outcomes we can also provide, but is to maximize the learning environments and to make sure that learning is enabled to its maximum extent and that data becomes available regularly so we can actually watch that learning transfer is occurring, or at least understand why it's not, which we, at least in my experience, we really don't know. Also, what we've suggested in here is that there'll be instruments that will be employed, which I'll talk about in a minute, but these will not only support the learning readiness, but also the human readiness levels as well. And what these are basically the measures that learning engineers would use to kind of determine whether each of these levels are ready. One thing I want to note is these are only drafts. So this is a proposal, and it's based on not just what I've experienced and others have experienced, but we are actually using this in some of our existing learning engineering projects going on for the Army today. And so we're sort of testing this out, but we're hopefully at some point another working group, national and international, might be created to either validate and or improve upon these. So these are some of the outcomes that I think would be low-hanging fruit for this kind of work. And that is making sure that we put standards into the acquisition and the research and development and the military industry. And some of these are, like, for example, the CISO standards. They're regularly used in simulations. But we also have a whole host of new standards being created by the IEEE LTSC, Learning Technology Standards Committee. And these need to be applied in more than just one application, but they need to be tested and they need to be improved. And the best way to do that is through these this sort of learning readiness methodology. It also hopefully will include making sure that we include, existing standards and tasks requirements like mission essential task lists and things like that, that we're literally training or testing these systems to make sure they optimize. So here's an example of the testing instrumentation that we propose should be part of these learning readiness measures, and which will provide the evidence to decision makers that, yeah, this system is going to be useful, or this content or this methodology. At the same time, it can also, we believe, support the human factors component as well. And this table here kind of shows what other folks have determined through their own research these instruments can provide in terms of measuring learning effectiveness. I should note, we are actually in the process here at UT to both replicate and continue this research with our own Army project. So we're looking forward to sharing that outcome with the learning engineering community in the future. So this is a cartoon that was produced back in 2023 as part of a poster that I thought was fortuitous to practices that we've been using to incorporate learning engineering in our own process for the military. And this is an architecture that we're researching right now and actually using for both the Navy and for the Army. And it's this, which is the heart of which is a U.S. Army adaptive instructional system called GIFT. It's an open source product that the U.S. Army DevCom sponsors, and we continue improving upon. But the nice thing about it isn't necessarily its tutoring capability, which is also a benefit, but is the fact that it collects data and we can use it against standards, both new and or established, and we can use it, especially in modern era where we're using more simulation-based content like AR and VR and other types of part task or full task trainers. And we can integrate it using these LTS standards, which the GIFT actually produces XAPI and use machine learning to extrapolate best practices or improvements that we need. It also has capability of supervising the outputs of the machine learning or the algorithms that are used within it. And that allows us to both do the analysis and to both improve the measurement process. And bottom line, that becomes a data strategy that we can use to produce that data I talked about earlier, that we can use for measuring whether learning transfer is happening and or to improve our systems. So we're actually using this architecture. This is a depiction of the simulations that we're testing right now. And yeah, it's all good. So hopefully that was informative. In summary, the challenge right now is the low training return on investment from learning transfer. And I'm not saying this is everywhere. Certainly there's parts of the government and military that are getting good learning transfer, especially the high-end institutions, tier 1 kind of stuff. But it does exist, and we hope to address it. And we think we can address it through the process of integrating learning engineering, which, as others have already said, isn't just another name for instructional systems design. It is actually integrating with an engineering approach and mainly focused or informed by science, learning science, and data, which is the key component of it. We propose that these learning readiness measures would be useful for advising acquisition, science and technology, as well as the military industry, and put us all on an even standard, and we can improve upon it as we learn more. And then we propose using the instrumentation I was talking about to provide the empirical data we need to support those people who have to make decisions on what content, technology are ready, as well as determining the return on investment that we're getting from our systems. And then finally, we suggest sort of a learning readiness assessment architecture, which I showed you, to support not only the testing, but the data collection and the independent validation and verification. So with that, and here's some references, and you guys should be able to access this brief at some point. And our papers there highlighted. If you have any questions, please ask in chat or feel free to contact me. There's my email, or you can look me up on LinkedIn. And thanks for your attention.
Hey, Kevin. So one question that came up from John Costa is, you mentioned Philips Level 5 ROI measurements. Is that a model you're using, or are you extending it?
I'm sorry, could you repeat that?
Yeah, so you mentioned the Philips Level 5 measurements. Could you elaborate on that? Is it tied to ROI? Is that model you're currently using, or are you extending it?
Oh, actually, Philips is a extension of what has been called, what is Kirkpatrick's levels of evaluation, which are basic smile sheets to, the end of course evaluation to determination whether how much the training is being used after training within the next 6 months, and then the long-term application, the learning transfer. That is a model that exists out there. It's written by Kirkpatrick. Philips took it to the next step and created level 5, which was, okay, how much return on investment am I getting from that training? So all this is published practices and principles that's been out there for a while.
Great, thanks, Kevin. Any other questions from the team? This is the time to ask in terms of the use case. can also reach out separately. We'll have some links to emails. You see Kevin's email there at the bottom. If you want to reach out directly to him on anything pertinent that may tie back to anything you're looking for your particular use cases. Okay,
Hi,
thank you, Kevin.
this is
Oh, go ahead.
Vlad Bukovsky. May I ask you, are you going to use artificial intelligence tools in order to improve instructional design, development?
Absolutely. So, as you probably know, to create those models, we need the data, and that's the rub right now, is because we collect a lot of data, or if we don't collect, we collect a lot of data, but it falls on the floor after the event, and that's usually the case in many cases. And at least the Army is working on new data strategies to collect data, and especially targeted for artificial intelligence. But as far as making it useful for evaluation and for design and development and automating those processes, some of that you can do with what's out there today, the chat GPTs and things like that. In the military, it's a little more challenging because we have our own, vernacular, and we have our own learning objectives and mission essential tasks and whatnot. And there are LLMs being created for the military that will eventually support all those that syntax and vernacular. But we need more training data of the practices we use for training itself. It's the methodologies that are kind of obsolete right now. And so yeah, that's we need to collect that data first, and then we can start probably using it better. And I should add that the GIF product, it doesn't use artificial intelligence per se. It uses sort of a rule-based, but it is extensible. And the cool thing is you can actually tap on a LLM and use that in place of that, which is hopefully what we intend to do in the future once we collect data to train the LLM. So hopefully,
Kevin, I can
Thank you.
jump on that from a Canadian point of view. So right now, our Defense Research and Development Canada, where all of our defense scientists reside, there's two primary projects going on right now that I'm happy to share links to after. One on the instructional design side is called ABLE, which is a really clever acronym for anything but lecture. And what they're trying to do is research how AI can suggest instructional design strategies based on the problem or the end goals of the user. And right now, myself, DRDC, and the Canadian Space Agency are looking at using LLMs backed with retrieval augmented generation, RAG, otherwise known as, to try to reduce hallucinations in our learning. Because one of our concerns is, especially when talking in the defense and aerospace, we can't have LLMs hallucinating and providing bad information. So we're trying to research how we can really drive that down to zero. I'm happy to share more information with that after, but that's the approach that at least the RCF is taking right now. I don't know if that's helpful.
Yeah, interesting point. I saw Gertrude mention in chat metacognition. 100% agree with that. I'd put 1,000% if I could. One of the things I would say is important. I mentioned earlier during Kevin's presentation, data is a through line of every learning ecosystem because we have to have empirical evidence in terms of what's working, what's not working, are we collecting the right thing? So a big discussion point that's been happening, particularly during the government military monthly MIGs, market interest group sessions, is what business questions or operational questions in terms of what are we trying to measure? So what am I measuring for? Ties back to data strategy. What data source or sources has that information, and is it relevant? This is really important for those who are trying to figure out where to start when you're dealing with a bunch of legacy systems that may not have the data you need, or it has partial data, or it's incomplete data set. But really drilling down into what am I measuring for? What am I trying to answer? Where is that data coming from? Am I getting clean data, consistent data that goes into a data lake structure if that's appropriate for your use case? And then how do I measure that my improvement? Because all of that is to establish a baseline to what I'm getting today. If you're looking at training efficacy, training efficiency in terms of speed of training, or cost benefit analysis, cost effectiveness, measuring against a baseline is going to be critical. Otherwise, you're just measuring things, but not understanding if it's going to be better than or worse than what you already have today. and that's a big conversation topic. So welcome the team, Seamus Pugh will come from the next slide, to join those MIGs and SIGs as appropriate, because these are the conversations we're having to establish exemplars, identify best practices, lessons learned, fail fast forward together so we can achieve those outcomes. Did I miss anything on that, Kevin?
No, one thing I wanted to respond to was a question on how active learning classrooms, the concepts of active learning classrooms are influencing the work. Funny you should ask that, because the project we're actually working on trying to apply these projects are in fact integrating a experiential learning, what we call a competency-based experiential learning model into the classroom. And our focus is at the U.S. Military Academy and the ROTCs. So incorporating that architecture that I showed you. So that is where we're trying to make the change in our little corner of the effort, to not to get away from the stand-up, didactic training approach, and actually immerse them into simulation and experiential learning. So, you ready for me to continue there?
Any other questions for Kevin before we move on? Okay, I think we're ready to move on. Okay, so this is the call to action. If you're interested in learning more in terms of how do I participate, how do I engage, how do I talk to like-minded individuals from multidisciplines across government, military, industry, academia, if you look from the left to right, there are special interest group for the ISICL, tied by IEEE. So there's one designated for design and learning, second one for tools and instrumentation, third for competencies, credentials, and curriculum, fourth for students and grads, and fourth for localization and globalization. And then across sector, from top to bottom, we have our market interest groups. There's one for PK through 12 education, higher education, workforce, and the one that Jason and I co-chair, which is the government military, which ties to specific use cases and problem sets and solutions for that sector, for government military specific type problem sets. So if you're interested, next slide, please. You can use this QR code in the bottom right, identify who your POCs are. You can also see their names right there, but you'll have emails for those to contact them if you want to get involved with any of those particular SIGs or MIGs. I'll leave that slide up just for a few moments. And then the presentation will go out to everyone as well, that you can access later if you need to. Okay, next slide, please. And then again, on the top right, there's another QR code if you're interested in learning engineering resources and tools. It also has information of how to get access to the Learning Engineering Toolkit book. I know there's some open accessible ones that are available now that was linked earlier in the session. But there's also just graphs, presentation, materials if you're trying to inform your institution or your agency or your business of how do you incorporate learning engineering into that. These are some great reference tools for you. Next slide. And with that, I just want to say here's the email list for those who are on this presentation today. Also some hyperlinks if you want to join the IEEE organization or ISIC organizations. And on behalf of everybody that was participating in this, Michael will have the final say. I want to thank everybody. If you have any questions now, this is your final chance for discussion before we close out the session.